Hello, ladies and gentlemen. Today I'm going to talk to you about hydrogen, helium, and the Big Bang. Before I can tell you why the amount of hydrogen and helium in the universe supports the Big Bang theory, you need some background information. So let's start here. You might have heard of dark matter or dark energy on a sci-fi show, but the thing is they're real. Okay, we don't know exactly what they are. We can observe what they're doing, but we don't know what they are. Like, we don't have the scientific tools yet to really understand them. And so for now, we just call it the dark stuff. But for this question, for how the hydrogen and helium supports the Big Bang, we need to look at the atoms in the universe, the elements in the universe. We call this stuff, scientists do, we call it baryonic matter because there's other types of matter too. But generally in science classes, they call it just plain old matter, the kind that you're used to. Hydrogen, helium, oxygen, all of those. Gold, those are baryonic matter particles. Okay, next part of background information, and this should be totally review. The elements are those atoms that are represented on the periodic table with these letters and numbers. Just to review, inside of a periodic table block, you get the chemical symbol, like for hydrogen, it's H, and then you get the atomic number, and the atomic number is the number of protons inside of the nucleus. So when we say hydrogen, we're not just talking about this great element, we're talking about a bunch of atoms of that element. And remember, atoms have subatomic particles, these little things that make them up. So atoms are super small, but they have even super smaller things that make them up. We've got protons and neutrons. They're represented here by the red and the teal. And then we have the electrons that are flying around. All right. What the periodic table block, that atomic number, is telling us, the really important thing, is how many protons are in that element. So hydrogen only has one proton, so it would be way smaller than this example nucleus here. Helium has two protons, and the number of the neutrons and the electrons can change in an atom, and it'll still be an atom of that element. So the thing that you really need to be counting for the most part to identify an element is the number of protons, and that's why it's the number here. Usually it's the most prominent number on the periodic table. Okay, last piece of background information you need is what's going on in the sun. So the sun has a nuclear reaction inside of it called fusion. This is when the nuclei of two smaller atoms joins to make the nuclei of a heavier atom. And why do we say heavier? Well, because we're literally talking about more little pieces inside the nucleus. So this is hydrogen with only one, this is a neutron and this is a proton. And this is hydrogen, but it has three particles in its nucleus. It has two neutrons. And you can have both of these types of helium form hydrogen form, because you're just counting the number of protons. In the sun, there's so much gravity and pressure and heat that these things are all flying around whacking into each other. And if they whack into each other just right, they combine and they make a helium nucleus. This extra neutron kind of gets pushed out and it releases a whole bunch of energy, and that's what powers the sun and gives us all of our energy here on Earth. So this fusion happens inside of stars. That's one of the parts of a star's life cycle, is that fusion is happening in it. Okay, how does this all come together to support the Big Bang? Well, before the Big Bang, there was the unimaginably tiny, hot, dense particle that had every single matter and energy in it. Okay, it's really hard to imagine. I can't imagine it myself. But it started expanding, right? And it was really super hot. It was so hot that you couldn't have any atoms form. Everything was just energy. And as it got bigger and bigger, we learned that when gases spread out, they cool off. And so particles started to form. We get neutrons and protons and electrons forming. At 380,000 years after the Big Bang, we have a bunch of atoms form. And these atoms are in proportion as they would be in the sun. So basically the whole universe at this time was acting like a star, and it had a whole bunch of nuclear fusion in it, and it was fusing just like the sun does, hydrogens into heliums. And when we measure in the universe, we find that 70% of the universe is hydrogen, 28% is helium, and that falls in line with the ratios we would find in the sun if it was doing a similar cycle. So this shows us that this happened in the past because we can find these numbers of hydrogen and helium in the present. All right, guys, enjoy your day.